Well, happy birthday to Stanley. What's he, 2 today?
Yeah, he is. Thanks, Mike.
Okay, let's see if that worked.
Yep, we can see it.
Okay, now I'm going to see if I go into the... Still good?
Yep.
Okay, so I'm just going to build a little bit on some of the regional curve talks that kind of follows a series of that. So this is a project that we're working on just outside of Denver near the airport on Box Elder Creek. So you can see, so the airport's over here. This is where our site is. Kind of see the watershed. It's definitely through the Denver area. So there's a lot of developments that are going on, some agricultural lands. So here's more of a zoomed in portion of our site. So we got about a mile of reach here.
Mike, I think you're on the. I think we have the wrong screen. Sorry about that.
Oh. Yeah, you're in preview.
Well,
yeah.
Let me. How's that?
Now we can see you moving.
Can you make it bigger, Mike?
I try to.
Can't you go to slideshow and go bigger? Can you go to the tab up on the top, so slideshow, and then go to?
Yeah, that's what I was in, and you guys weren't able to see it.
Oh, okay, sorry.
Let me see if I.
Mike, do you have 2 monitors right now?
Yeah.
It might be on monitor number 2.
There we go.
There you go. That's it.
Okay.
That's it.
All right.
Thanks, Mike.
Well, this will be fun when we try AutoCAD. So okay. Okay, so Box Elder Creek, here's our site. This is the airport, and then kind of the surrounding area, a lot of farmlands, and then development as you go further south. This is a zoomed in section of our projects, about a mile of reach. We're looking at doing this as a mitigation site, and looking at just the watershed. It's a pretty large watershed. It's 236 square miles. Gets about 18.5 inches of precip per year. So, looking at some of the watershed coefficient factors and some of the things that we've looked at in the past that Dave's has talked about, this would, give us some kind of indication of where we might expect our cross-sectional area to fall in. So a couple pictures of the sites here. Here is a cross-section coming right through the site. So, one of our first observations was looking at this is that for a 236 square mile drainage area, you would expect it to be a pretty large river, right? We weren't really seeing that kind of in the field. Here's a couple more photos of it. You can see our flags where we're finding those bankfull high and low indicators. They're clearly out there, definitely depositional and scouring lines, so easily identified. But again, for a really large watershed, this was kind of a little surprising. So here again, you can see where our bankfull calls were. Inner berm of the site. So looking at some of the regional curves that we've had in the areas, so Piney Creek, it's in the Denver area, and then the Wyoming regional curve, just looking at what I would expect to see something with a 236 square mile drainage area. I'd be looking at something with a cross-sectional area of greater than 100 square feet. And based on some of the photos, I'll go back, that doesn't look like it's going to be a 100 square foot channel. So kind of, this is a good example of why these mini regional curves are important too, and trying to identify, the differences in what we see and being able to document that. So some of the cross sections that we took, we're looking at where our values were coming closer into that 30 square feet, which is significantly different, magnitudes different than what we would expect. So here's another cross section through there. So one of the important things to note on this is just because this doesn't fit within that regional curve, what we find in the field, we have to document and explain. So, we could easily move our bankfull up to here, and it's going to give us a larger area that will make it fit closer to what some of the published regional curves that we have are. But based on what we saw in the field, we have to call what we call and then figure out from later. So that's what we ended up doing. So this is where that cross sections from our site kind of falls within some of these regional curves. So it's not really close to anything that we've really seen before. So what we decided to do was within that 236 square mile area, Brendan, Luis, and Ryan were great by being able to help us put together within that watershed kind of a bunch of areas that maybe we should go way up in the watershed and collect a whole bunch of stuff and put together a mini regional curve to sort of figure out, is it just this area of our site, or is it kind of, what can we kind of learn from this watershed? So we picked a whole bunch of sites all the way through that watershed. The furthest point, I think it took about an hour and a half or 2 hours just to get there from our site. So I think we collected close to 35 or 37 different sites that they put together for us. From that, this is a location way up in the watershed. Still, you know, similar size to what we're seeing at our site. And as we go further down, this is about midway through the watershed, and it's definitely bigger than what we had on our site. So plotting all these points, which these guys did for us, which turned out great, is that we see the light blue and the orange are bankfull high and bankfull low calls within there. So from our watershed coefficient, which, you know, we would expect to see with 18.5 inches of rain, probably have that y-intercept or watershed coefficient be kind of closer to that 16 or closer to that 12 range, and we're falling significantly lower than that, between, you know, 3 and 1.5. It's not saying it's wrong. It's just this is the relationships that we're showing. So that's the importance of doing this, is now that we have enough information to sort of justify it. So that's kind of what our that's what we ended up coming up with. So this is going to help aid in my design, as well as being able to explain what we're seeing in that watershed. So looking at this would be a cross section through our site. So this little bit higher floodplain terrace here gives us a larger area, but that's where we were finding our bankfull features at, just because I can move it in the cross section to make it fit better. It's definitely something that we want to try to get away from. You really have to, you know, trust the data that you find out in the site. So some of the preliminary conclusions that, you know, the curve definitely falls lower than expected. And then it does follow the trend of a Cherry Creek, which we've been working on in that area too. And then some of the flows have been affected by the development, groundwater withdrawal, and diversions. Our bankfull flows we're finding to be around 100 CFS based on our cross sections that we've found. If we look at what the effective model is for our 2-year discharge, that's closer to that 370 CFS. Which falls within our stream stats and some of the other stuff that we find. So, you know, what this is definitely telling us is that need and that importance of that floodplain terrace to handle those discharges in these urban channel settings. So, you know, that's sort of what we came up with for that one. Oh, I think I lost the screen.
Yeah, we now see you and Levi looking at the at Lake Michigan.
Let's see here. Well, I lost it, but so that's definitely one of the things that we've learned on this one. So again, just stressing the importance of these regional curves. It's to be able to identify areas when it does fall through, just do further investigations. So. So that's kind of that for that one. There we go. Is that back on? Or...
Yeah, we're back on the PowerPoint presentation.
Okay. So we definitely fall below that curve, but so that's kind of what we did for that. So if there's any questions, we'll take them, or we can move on. The other thing I was going to do is just do a quick demonstration and just an AutoCAD. I think I'd like to try to do at least every Monday call, just a quick tip or AutoCAD kind of tool just to kind of, share with people what we're learning too. So,
Mike, I've got a question.
yeah.
So when I look at the two curves, it looks like it's pretty consistently undersized the entire length of the channel. So
It is. Yeah.
it doesn't look like there's like a local pumping effort that would create a problem in a specific location. It seems to be a consistent issue the entire length of the watershed. So, I mean, is it essentially a losing reach its entire length? I mean, that's what it would suggest.
Yeah, it definitely could be. I think we're still trying to figure that out. One of the other kind of interesting things on this is if we look at the see if I can get back to this. If we look at the actual watershed, it's really long and skinny too, which which is different than what we've seen typically before too. So it might have to do something with the watershed size and shape of it as well. But it definitely probably is a losing reach. I know that with a lot of the groundwater pumping that they've done, it's a sand bed system, so we depleted that groundwater table a little bit, so a lot of the water is probably going through. But I don't really quite know all the answers yet. Still kind of trying to figure that out as we go. But yeah, it's a good point.
I mean, even if you were lowering groundwater, I mean, you'd be lowering it. I'm assuming groundwater's very deep at this point. So wow, it's really difficult to understand, Mike. I'm struggling with that. Yeah, something we'll definitely have to figure out too. It's in the slope of it too is a lot flatter. We're at 0.44 in a lot of the other curves that we've been looking at developing are always have that slope of around 0.67 to 0.68. So that's a little bit different too. So yeah,
once we write this up, we'll be able to give a better description of explain what we're seeing out there.
it's an interesting point though, because at the top end of the drainage basin, the channel's more quote normal, and it gets worse the further down the watershed you move. It diverges further and further.
Yeah.
One of the things that we're seeing here too, Brad, is all the tributaries in the headwaters seem to be dammed up for irrigation purposes. So they're all in agriculture. So even though there's not a whole lot of groundwater pumping, all these tributaries are pretty short, but yet a lot of them are dammed up and the water is being taken out of the system for irrigation. So, a lot of them are.
Go ahead.
In the 20s and the 30s, there's a lot of soil conservation issues here. There's a big flood in the 20s, and then of course they were hit by the Dust Bowl a little bit on this side of Colorado as well. So a lot of SCS ponds that are completely evaporating all the discharges from their small tributaries.
So rather than losing it to groundwater, we may be starving it on the surface.
Yeah, that's one of our thoughts. We still don't know. we're trying to figure it out, but
well, you guys probably know, but evaporation rates in the prairies are outrageously high.
Yeah, with such a high convective forces out here too. I mean, because this is those areas where the wind goes whipping down the plains, type of thing. So.
Well, to give you an idea, Dave, Lake Diefenbaker, which you've seen, I don't know whether Mike has.
Yes.
Basically, the under drought conditions, the riparian outflow is 50 cubic meters per second. They lose more than 50 cubic meters per second to evaporation off that reservoir.
I believe that. That's a huge reservoir too. And these surface areas shouldn't be anywhere in comparison to Lake Diefenbaker, but it's still a huge evaporative loss, and they're just not allowing anything except for infiltration to go downstream.
Yeah, just trying to give you an idea in terms of the magnitude you can be losing to evaporation. It's pretty staggering.
Yeah.
Hey, I have one question. This is Josh Gilman. It's great to see everybody hear everybody's voice. I think it's an important consideration, the source and supply for the perennial sources. But I've seen similar to what you guys are feeling, Dave, working on some of our semi-urban streams in rural South Carolina, where we have ponded systems, dam systems upstream. That shaving, and we've affected the dominant process of shaping the channel. You know, these are still sediment-driven processes, but the dominant process is largely affected by that storage and you know, I don't know. You have to factor in a lot of things to come up with a good hydrology for that. But I think that's a good point. Your upstream system's being dammed, and so it's behaving like a smaller system might, or that larger channel that you didn't identify the bankfull indicators is behaving like a much larger ephemeral. You know, if you were to look at it from that scale and back away from it and not looking at some of the more refined nuances in the channel, like you said, it seems to fit the curve in one way, but not the way we expect it. So interesting. Thanks for sharing.
Yeah, it's always good to find, you know, new relationships that kind of surprise us. So this one definitely surprised me a lot. So it's kind of fun trying to be able to figure it out. So I appreciate those comments. Sir. Okay, I guess we'll move on. Does everyone see my AutoCAD up? Did I do that right?
Yeah.
Yep. Okay. So I'm just going to go over a quick example. Oh, let's see if I can. So, you know, I'm sure people are probably familiar with recording macros in Excel. Anytime you kind of have a repetitive task or something that you find yourself doing a lot over and over, you know, macros are always really good to do in Excel. One of the things you can also do macros in AutoCAD too. So I'm just going to go through a quick example of how we would do that. So in our manager tab up here, in our manager menu, we have our macro, or we have all these ribbons that come up, and here's for our macros we have one that we can call record. So if we want to start just like what we do in Excel to record macros, I'm just going to go ahead and select the button. So one of the things that we do a lot of is we'll bring in points to create our surfaces through our breakline program a lot. So it's kind of a repetitive task where we have to enter a bunch of numbers in for the menu values. So I'm going to go through that process while recording it. So I'll go into my points, alignments, import from file, select my output file, and then our commands. It prompts us for commands. It needs us to select our file format, what kind of limited it is, and just kind of some default values. And then it asks us to select our alignment. So every time we do this, we have to go through that whole process each time. So as I import the data points in, there's our points for our surface. So now if I make any kind of adjustments to that, I'll stop recording my macro now. So now if I make some adjustments and I need to do that again, or if I'm going to do that again on another alignment, since I recorded that macro and it's a repetitive task, now I can just go ahead and play that macro, and it just prompts me right in to select my output file. So as before, I would have to go through that process of entering in, you know, what kind of file format it is, and the other prompts that it asked me for. I don't have to do that anymore. So it kind of saves a little bit of time, but now it puts my points in. So I don't have, you know, it's kind of speeds things up a little bit, but I guess more of the point is any kind, you know, there's ways to record macros in AutoCAD like you can Excel. So any kind of task you find yourself repetitive doing, try to, you know, record a macro. And then the other really cool thing about AutoCAD 2020 is this Dynamo. Does that come up?
Yeah.
Okay. So Dynamo is a program that they just released within Civil 3D 2020. So it's a way to program for people who aren't programmers, for engineers and architects and things like that. So it's allows us to import in files, and then we can get basically it's running through a way to be able to do kind of the same thing, repetitive tasks, but also program it in. So as we change things, they can dynamically update. So I think the way that we'll probably go in the future here for building our stream designs is going to be looking into this here and then building all of our custom assemblies for our streams with our pools and riffles and just get rid of the brake line program together. This is really exciting. I just kind of started getting into it, and since I'm, you know, home a lot more and have some free time, I think it's something that we'll dive into and look at more. But you can do some YouTube searches on Dynamo Civil 3D if you guys are interested in it. It's really cool. I think it's gonna be really powerful, and I think it's really gonna help us progress, advance the way we do our stream designs in the future too. So I'm excited about this. And then definitely encourage people to use the macros if you guys are finding yourselves doing anything that's kind of repetitive. So that's just my quick AutoCAD tip for the week. And then next week we'll look at doing a few different things in AutoCAD that I think will be helpful for our stream designs. So
thanks, Mike, for that AutoCAD tip. Do you have any stock tips for the day?
Stock tips? No.
Don't sell.
We all use a good stock right now, Mike.
Sure.
Other than cascade companies.
You can invest in my company.
I was thinking about the Bates Casket Company.
Yeah, right.
Zoom would probably be a good company to invest in right now.
That's true.
All right. Well, we moved on a little bit longer than we have before, but that's okay. So we'll leave it open if anybody has anything they want to add or comments about the week, or if there's kind of things that you need help with. I'll just leave it open to anybody else to add for this week, and then we'll hang up for the week. So.
Hey,
I don't see Matt. Go ahead, John.
This expands a little bit on what George's question was earlier about the president, but a little life story the other day was the first day that our church around here was shut down and couldn't go, and the National Day of Prayer, and so we huddled up in the living room, and my 4-year-old, we got to him around the circle, and he said, I said, Oliver, is there anything you want to pray about? He said, yeah, Daddy, I just want the president to quit coming on TV. And, you know, I was kind of taken back by that. And I said, Oliver, what do you mean by that? And he said, well, Daddy, he said, you know, I keep looking at TV and I see the people's faces. And he said, I think that the country is bad off. I said, yeah. He said, but by the president not coming back on TV anymore, I just know that Jesus is taking care of it and that Jesus can fix everything. And so, you know, the comment about the humility of the president, I think if we all just realize and you know, the voice of babes, it's amazing that a 4-year-old can recognize that Jesus has got it all.
Yeah.
Be like the children.
Yeah. When you know, when the apostles were arguing, the disciples were arguing who was the greatest among them, Jesus was off to the side, and at that time they didn't think Jesus was listening to them, but he knew what they were saying, and he pulls over a child next to him. And he says, if you want to be the greatest of the kingdom of heaven, you have to come to me like this child. And I think we lose that a lot of times. This is our week. This week we can think of it more like a child. You know, are there things that we can just come to Christ like a child this week? I mean, we can't control the sin. But, you know, if God has it under control, you know, I love that. Thanks, John.
No problem. Proud of little man is all I got to say.
He's got the humility of a child.
All right. Well, hey guys, we'll let you go. I'll be on the line until whoever signs off, the last person. I'd really appreciate all of you getting on the line. Um, I hope this group can be somewhat of an encouragement to you as you are encouragement to me. Thank you.
Thanks, Dave.
Thanks, Dave.
Thanks, Dave.
Great.
Appreciate it.
Thanks.
Are you guys going to be able to make a cake for Stanley, or what are you guys going to do?
Oh, I'm going to show you here, Mike. Stay online for a second.
Okay. All right. Nice. Very cool.
I want to see a
Yes.
picture.
Yes, Scooby-Doo's his favorite right now.
Right
And
on.
yesterday, we took some time as a family to make a Scooby-Doo cake for him. So
Cool, man. Well, hope you guys have fun.
mostly Abby, Ida, and I, but so
Yeah. Well, cool, man. Well, tell the little guy we said happy birthday.
I will. We'll see you, man. Have a great
See you, buddy.
day. Thanks, Mike.
Yep.
Hey Dave, I got a question for you.
Yeah.
Do you have any guidance you could point me to for urban drainage? Issue I'm having is I have a developer that's wanting to cross our water line with a drainage swale, and I think they're just doing grass. So basically from a detention pond to a grass drainage swale, but they're going to be cutting down and down to whatever 3 feet above the top of our water line. And so,
Yeah.
of course, they're going to develop this. It's a straight line drainage in a, suburban rural area. And, when they're done, they're going to leave the grass and the maintenance will be mowing. But we've had issues with erosion over our lines. And, some people are telling me, hey, maybe we should make them do a grouted riprap over the top of our line. But I'm seeing grouted riprap around here in some of our creeks, and the water's flowing under it in our parks, So I'm just trying to maybe a matting or something that's going to last long term when the developers are long gone. And unfortunately, we can't ask them to put in meanders and natural, a natural stream. But you know how the engineers are; they develop and they leave. And I don't want to approve cutting down that grade without any sort of long-term protection. Is there guidances that you would point me to on type of materials they could use?
Yeah, and I'll point you in a direction of somebody that could kind of that deals with the same thing with urban drainage and flood control district or mile high flood district in Denver. So they deal a lot with the same exact issue of long-term maintenance on these lines and how to get something to low, high functioning, low channel, high functioning, low maintenance stream channel. Related to matting, there's a couple of different mattings that you can use. All of them, the issue is if you erode downstream and then the head cut just works up through the matting, it doesn't really help any. So it's really systematically trying to get the grade set to something that will be resistant with the vegetation potential that could be there in the future. So I look at things like instead of permissible velocity, a lot of times I'm looking at the critical shear stress on these things and saying, okay, well, what is it that the vegetation will withstand for critical shear stress here? So if you're going to be a grassed waterway, you're probably designing a critical shear stress about 1.2 to 1.4 pounds per square foot. So that means you're either going to have to limit the slope or increase width so that you're not concentrating flow that's going to go above that threshold. And that's how I'd look at it mostly. Josh, do you have things that you've done in Charlotte or that region that are kind of similar, or do you do things that's slightly different? Oh, you're on mute, man.
Guys, Kevin, I think that's really important question, because understanding the maintenance in the long-term management is really a constraint. It's a huge constraint. That's how a lot of our streams got to where they are. And I think you're very mindful to be like, well, they're going to mow it. You know, what are we going to do? And some of the, you know, obviously, putting in stone presents a lot of challenges. I think a couple of things I've been trying to encourage, and I like the urban setting as a ministry for stewardship, because it's a really good place to connect with people that have they have a direct connection to some of the resource management that we're interested in. And so, you know, park planners and utility folks and all these different sectors. And so it's a really great forum to just share good stewardship ideas. But some of the things that I encourage, depending on the stream, depending on the bed load, depending on, you know, how much sediment gets transported, yeah, definitely priority 4 type restoration and big stones if warranted. It sounds like you've got a lower energy system. If it's flat enough and, like Dave says, permissible for the grass surface, that's great. That's a great plan. But you got to always have your plan B in these urban environments. And sometimes, maybe perhaps trying to align that and promote a little bit of vertical geometry if we can. I know it's really hard when people are digging ditches to say, you know, can you make this part of the ditch flatter and right here make it a little steeper. But if we hide some stone underneath the grass, that's something I like to do, is put in some riffles where the riffles should be, and based on what is the diet of that stream now. You know, it's not the natural channel. We're seeing some of these departures that Mike and Dave have been presenting. But what is the diet? How much water is coming, and what is the process? What is the dominant discharge? What is the sediment coming to it? A lot of times we've starved it from sediment. So given the sediment and water diet that the stream has, what would be an appropriate, a corresponding or a matchup for an active channel? And then also in these urban systems, looking beyond that, because sometimes the departure from bankfull is, it can go both ways, as some of the data that we collect, you know, shows in urban systems. So also being mindful for the larger events, you know, whether it's a backwater scenario or not, these floodplains are just as critical in these urban environments. We don't have a lot of them. So even if you capture your bankfull channel and you've got a little bit of stone buried underneath some grass, and you're able to get a little bit of variation in the vertical geometry, or even, you know, maybe you elect to use a herky robust structure that's well crafted to lose the energy at the top end of your system, or sometimes at the bottom end. I don't like putting things like that at the bottom, but yeah, I think you're on track with thinking about turf reinforcement matting to get good vegetation established. But if you hide some stone underneath it, sometimes that's a good trick. And make sure you go wide enough, because you don't want your channel to breach it, go around it.
That is something I was thinking about, because we do have an easement there. We would make them do the entire width of our easement to protect it. But, you know, as I'm taking my kids on walks every day, I took them out when this first started, and we did stream measurements at the park. You know, it was a lot of fun. But in the park there, yeah, there's 2 areas where they armored all around these bridges, these walking bridges, and the water's flowing under the grouted riprap, you know, completely flowing under it. So I did think about putting, even if it's not solid, I mean, and if we put it under the grass, like an articulated concrete block, just something to hold it together, where your roots could go through and around those, that would be something. But I think they have like a 1 degree grade on this, but you would suggest maybe a few different grades here and there.
Yeah, I think I'd suggest just looking at having them look at the hydraulic geometry by stages. So looking at what the shear stress is and the velocity is both upstream, downstream, and through the area. And if there are hidden kind of permissible velocities that it can be designed to, or if you can get a material in there that can design, then that's going to help guide it. But don't let them just give you the hydraulic geometry just over the pipeline, because you're also going to want to look at what's downstream as well, because your potential for your head cut's what's going to get you. I mean, the other option is just, have them armor the entire thing. But if you're trying to get away from armoring it all, then you're going to have to make sure that their permissible velocity and their critical shear stresses are not exceeded. So.
Okay. I mean, I can definitely put it on them. They're the developers. They need to do
yeah.
something to protect it.
That's, I'll give you a reference of an example urban stream project that we've done for Denver Metro that looks at hydraulic geometry by stages and critical shear stress and some mitigation methods for critical shear stress. So I'll send you that over, and then you can say, hey, we'd like to just see something kind of like what they've done here, and then that will at least let you know that that they've looked at the shear stress, they've looked at the velocities, and that they're not expected to exceed either them downstream and then work ahead, cut up through the system. We've been struggling with a lot of the same issues on a lot of pipeline crossings for natural lands in Colorado, and they're so quick to say, okay, we're going to put in this pipeline, and then they just leave a whole bunch of bare ground, and it creates a instability that wasn't there before. And then the sites are so fragile that they were going to be stable if there was vegetation, but once there's no vegetation, then it just unravels everything. So,
yeah, I mean, it's
really,
probably going to be decent around here, clay soil, grass growing. It's not going to be a steep slope, but it's a short stretch from the detention pond to the ditch. But like I said, they'll put it in, do the best they can, but they're not experts. They're just developers, and once they're gone, they're gone.
Yeah, a lot of them are.
I was going to say that connection to the detention pond is pretty critical, though. It doesn't matter how small the channel it is. That's a very critical component.
Mm-hmm.
What we've seen on places down in Houston is people will do some pipeline work, and that vegetation is intermittent or ephemeral, but that vegetation was able to withstand 4 pounds per square foot for a force being applied to it. And then once they take it out, it's able to withstand about 1 pound per square foot. And then it just, you may disturb 100 feet, but that entire 100 feet moved almost a flat slope, and then it creates a head cut that goes above that 4 pounds per square foot and kind of gets underneath everything, works its way upstream. So definitely a concern. But I'll give you an example of that you can send out to them, and if they have any questions, you can come back and ask if you want, and I'll copy Josh on it too. That way, if you have anything that comes
that'd be great.
Josh,
I'd be glad to look at something. Anything to divert from what our daily focus is. I need a diversion.
All right, I appreciate it, guys.
All right. Hey, I love seeing the kids, Kevin. How do you spell Emery?
E-M-E-R-Y.
Yeah. Okay. Good. Yeah, we have a son that's an Emory, but he has an O instead of an E. So.
Okay. Yeah, there's no escape. As of last week, we were in the office 1 day per week, and now it's all 5 days at home. So I got to run in and get my phone forwarded correctly. But yeah, we're gonna be
all right.
Yeah, I have some other friends. I have other friends in the Dallas metro area that are kind of on lockdown and stuff too. So we've been hearing that through their Facebook feeds and stuff, that everything's pretty slow in Dallas right now. So
it's nice though. It's relaxing.
Yeah.
It's time to appreciate some of those blessings that we take for granted other times.
Definitely. I know there's a lot going on, people suffering, but here in the home, we're just trying to do the best we can and just enjoy our time, My wife maybe not so much, but That's why I'm in my office and she's schooling them.
That's right.
Yeah.
We're normally homeschoolers, so it's not that big of a deal for us.
Well, our kindergartner is probably not ever going to go back. So.
Oh, okay. Good.
He learned everything he needs to know in kindergarten.
Yeah.
Anyway, I just wanted to say, hey, Dave, thanks for hosting. I realized my sticker was covering up my window.
It's okay. It was nice at the end to see you.
I was too proud to show my uncut hair. Yeah, this is COVID hairdo.
Nice.
Barber, you know, so my wife doesn't mind it. My kids are calling me hippie, but thanks for hosting. And yeah, I like Mike's presentation. We've seen a lot of that same response in the watershed. And I secretly have a passion to do a study on looking at watershed geometry, and not just the planform geometry of the watershed, but I think the hypsometry is also a good ultimate fingerprint. Things like that. I think are important to look at. I think if we study the watersheds and some of their markings, some of their signatures, I think we might be uncovering more with how regional curves vary, and rather than regional curves, we'll call them watershed curves, because it won't matter where you are. And then we'll be able to understand some of these urban, like Kevin's system or other urban systems, and how they depart from the explanation of departure from a watershed curve. But it's comforting to see that even in Denver, even in out west, you guys are seeing a similar watershed response to these ponds or stream as a response to the ponding and the suppressing of the bankfull events. I think storage is an important factor, but I really, in my opinion, maybe because I'm down in the wet south, the storage is a huge factor in our channel.
Yeah, the length and width ratio of the watershed seems to be a huge impact to the slope of a regional curve. So I haven't verified any slopes of regional curves that were less than 0.5, so drainage area of 0.5, that were not these long dissected curves, that were not these long dissected drainage basins. So we just have these incredibly long fingers. And I'm wondering kind of if there's something we can, eventually we want to get to a point where we can produce some sort of reasonability and say, okay, this is where we're at, and we expect to have this size channel given rainfall. And I think we're getting close there if the watershed's kind of that uniform watershed that shapes like a pear or something like that. But here where we're really just like this long finger, I think that there's something that we're seeing that's very unique here that can be transferable to other areas. And we will have some storage, but I think there's something else that's coming on here too.
How steep are the upper portions of the watershed to the headwaters? Are they steep? Is there very, not real steep, but is there, like, what percentage of the watershed is steep versus the valley bottom, which might be flat?
So for us, I wouldn't consider much of it that steep. I mean, we have sections that are 2% on the channel, but that's about it. I mean, we don't have anything that's much steeper than that.
But
this is all weather. Coming into that.
Yeah, the tribs or.
We don't have that. I mean, we might have some 4% tribs coming in, but they're short. This is all weathered. So this is all former areas of foothills that have been weathered over time. Historically, geologically, this would have been a lot steeper peaks. And of course, everything's kind of weathered and filled in. So a lot of sands that are there. These would have been the protection mountains for the Front Range before they got eroded. And now, of course, the protection mountain for the Front Range is Pikes Peak and everything else. So it's kind of working its way westward at its slow rate. So that's part of the reason why we're seeing potential for losing reach is the interesting thing is that the formation of these channels and the riparian signatures on these channels are related closer to our regional curves that we have for other places. But yet the channels that have reformed inside of there are small. So it seems to be anthropogenic in nature more than geologic in nature, because we have signatures of cottonwood galleries that are at widths that we would expect based on regional curves, but yet these cottonwoods are now high and dry, and even the plan form of the creeks resemble something that's a lot larger. So we definitely haven't figured it out. We have two of these watersheds that are kind of heavily eroded, dissected watersheds, and then we get into the Denver metro area, and then we start getting everything from the hill slopes now that are significantly different sizes and shapes. But we have these two long fingers for watersheds. We also have one farther east that's over called the Sandy Creek watershed. That's where the Battle of Sandy Creek was fought years ago during westward expansion and stuff. So we'll be looking at that one too. So we want to keep on going a little bit farther east and see if we can understand anything in reference to other watersheds where there's no water development coming out of it, where there's no, I mean, there's irrigation, but there's no like pumping of groundwater. Right now, the watershed right to the west of this one is heavily pumped for groundwater, but this one's not heavily pumped for groundwater. So we're trying, but yeah, we always figured the other watershed, the reason it was so flat was because of the groundwater pumping, but now we're over here and we're like, oh, maybe it's not, maybe there's something else that we don't understand. So. That helps us with humility.
Huh?
It helps us with humility.
Yeah. Well, anyway, I'm gonna go. I'm gonna bounce now. Kevin, good to see you, and David, thanks for hosting. And yeah, I'll try to tune in again next week. 8 o'clock is harder now that I work and live at home. 8 o'clock is a different time than it used to be. You know.
Well, we were gonna change it just to make it easier for people. But since everything kind of broke out, you know, a lot of people are kind of attending right now, and people's schedules have completely changed. Like one person that could never make it was Mike, but he used to take his kids to school, and now he's not taking his kids to school. So at some point, we're willing to change the time. We just haven't seen quite the need yet. So.
But I need to get up and go. It's Monday, you know, time for the weekend anyway. Well, I'll be praying for you guys and for everyone. You know, it's a special time, and yeah, connecting with the kids is real important. You know, making the best use of this time. A lot of people have difficult home lives, and Kevin, like you said, it's every moment at home, even the trials and tribulations, is truly a blessing. Hopefully you guys can walk with grace and peace in your hearts, and we'll talk to you soon.
Hey, thanks, Josh.
Thanks.
Bye.
See you, Dave.
Bye, Kevin.
Hey, we'll see you, Kevin.